We need to solve completely the simultaneous equations, these two. First, we need to show that these equations are compatible. When these equations are compatible, if this Lagrange's bracket is 0, then we say that these equations are compatible. Then we need to get the solution for these equations. Before that, we need to read this remark, which is helpful. The equation z equal to px plus qy is compatible with any first order partial differential equation fx, y, z, pq equal to 0, which is homogeneous in x, y and z. Second remark, if fx, y, z, pq equal to 0 is a homogeneous equation in x, y, z of degree n, then this f can be written as z the power n phi of x by z, y by z, pq. We can write this function in terms of this with the power of z, right? So in this case, we are having the second equation. This second equation can be written in the format f equal to z power something, and then in terms of x by z, y by z, pq, then we say that this is the homogeneous equation in x, y, z. So these two equations are given to us. We can write this first equation as we take g to be equal to px plus, from here, px plus qy minus z. We take z to the other side and write this to be equal to g. Similarly, for this equation, I am writing f to be equal to 2xy p square plus q square minus z into y p plus xq. So for that, I need to get this equation in the format z power n phi of x by z, y by z, pq. I'm having the power of z over here. That means I need to take z common from this equation. I'm not having z over here, so I'm multiplying and dividing by z. I'm having two variables over here. Let me multiply and divide by z to x and y, and here I write z square. Is it okay? Fine. Minus, to make the power of z to be same, again I need to multiply and divide by z. Is it okay? Fine. Alright. Now I take z square common from these two terms. Here I am having 2xy divided by z square, and here p square plus q square minus yp divided by z plus xq divided by z. I hope it is very clear. Yes. Now if you notice that this is your homogeneous function having the degree 2. What do you mean by a degree? The highest power of the variable, right? So I'm having the degree 2. This is your homogeneous function in x, y and z, right? So now by that remark, if I'm having this kind of function and also with this equation, then these two equations are compatible, right? We don't need to find the Lagrange bracket. We don't need to find this condition. We don't need to check this condition, because by this remark we are clear that if I am having this equation with any first order partial differential equation which is homogeneous in x, y and z, then these two equations are compatible, and we have got this function f to be the homogeneous function in x, y and z, right, with degree 2. So this equation from this and this equation, these two are compatible. So by remark we are saying that f and g are compatible equation. From here, if I get the value of q to be z minus px divided by y, because I need to get the values of p and q. So if I put this value of q in this second equation, I get the value of p. By first equation, we are getting the value of q to be z minus px divided by y. So from second equation, putting this value, we get, okay, we have 2xy into p square plus q square. So q square will be z square plus p square x square minus 2zpx divided by y square. So I am adjusting this. It is y square and here y square. Okay, equal to zyp plus xq. So this is equal to z yp plus x into q, multiplying x with q. So this is zx minus px square divided by y. So adjusting again this y, we have here y square p and here divided by y. This y is cancelled out with this. So this is 2x divided by y. From both the sides I am cancelling this y now. From these two terms I am taking p square common. So this is 2x x square plus y square into p. And then 2x multiplied with z square we get plus 2xz square. Then when multiplying with this we get minus 4pzx square. Yes, minus 4pzx square. Then z is multiplied with this. This is equal to zy square p plus z square x minus px square z square. Sorry, this is px square z. So this is 2x into x square plus y square into p. This minus 4pzx square, and from this we get minus 3pzx square. Then plus 2xz square. Taking these to the left hand side, minus zy square p minus z square x equal to 0. Xz square and minus z square x becomes xz square. So writing the first term as it is, taking z common from these two terms, minus z common from these two terms, this is 3px square plus y square p plus xz square equal to 0. We can also take this p outside from this bracket. So this is 3x square plus y square, right? Sorry, this is p square. Very sorry, this is p square. Let's write this term to be minus zp. In place of 3x square I am writing x square plus y square plus 2x square, right? And now separating this, we get minus of zp x square plus y square and then minus of zp 2x square, right? Okay, now we need to take x square plus y square p common from these two terms, and let's take xz common from these two terms. Taking minus common from this so that I can get the same term, and now taking 2xp minus z outside of these two terms, and inside it is p into x square plus y square minus xz equals to 0. So we are getting two values of p. From the first bracket we get p is equal to z divided by 2x. From the second bracket we are getting p equal to xz divided by x square plus y square. So these two values we are getting for p. So we are getting the values of p in terms of x, y, z. Also we need to get the value of q in terms of x, y, z. For that, let's put this value of p in our given first equation, that is z equal to px plus qy. So first value z divided by 2x. So this is z divided by 2x into x plus qy. Xx cancelled out. Taking z by 2 to the other side, we get z divided by 2 equals to qy, and we get q equals to z divided by 2y. Similarly, we can get the another value of q to be, for using the another value of p, we get q equal to yz divided by x square plus y square respectively, right? So these are two values of q for these two values of p. And now to get the solution, the equation dz equal to p dx plus q dy also takes the form dz equal to, I'm using the second value of p, that is xz divided by x square plus y square dx, plus for this value of p we have got the value of q to be this. So using the value of q, yz divided by x square plus y square dy. If I take z common from these two terms and taking that z to be in the denominator, and then we have x dx divided by x square plus y square plus y dy divided by x square plus y square. So which can further be written as x dx plus y dy divided by x square plus y square, which can be easily be integrable. We can write this to be equal to derivative of x square plus y square divided by x square plus y square into 2. Because when you derivate this numerator, you are getting 2x dx plus 2y dy. So for that you need to multiply and divide by 2. Right? So that numerator becomes dx square plus y square and denominator is 2 into x square plus y square. So taking this 2 to the other side, so when integrating both the sides we get 2 log of z equals to the log of x square plus y square plus the constant, or it can be written as log of z square equal to log of, okay, let me write this constant to be log of constant c, x square plus y square plus log of c, or it can be written as z square x square plus y square into c. So this is the one way of getting the solution. Another way, by putting the first values of p and q in this. The second way, I'm going to use the first value of p, that is z divided by 2x dx. For this value of p we have got the value of q to be z divided by 2y dy. Taking z to the other side when taking common from these two terms, so this is dz divided by z equal to dx divided by, okay, let me write half outside, plus dy divided by y, taking 2 to the other side, and now integrating both these we get 2 log of z equal to the log of x plus log of y, and the constant, let's say log of, okay, let me take that constant to be c1, and this is c1 dash. So taking this constant to be log c2, so this is log of z square equal to log of xy c2. So that is z square is equal to xy c2. So this is another way of getting the second solution. So both these solutions are the common solution. This is the another common solution. So we have got two solutions. One is this and the second one is this for the given differential equations. Okay, thank you. Stay blessed.